All right, boys and girls, now we're moving on to example 3, which is deriving a triple angle formula. Okay, so for this example, they want us to rewrite sine of 4x in terms of sine x and cosine of x. So if you notice, sine of 4x, this is actually not triple, this is actually quadruple. So we already did a double angle, and so now we're doing a fourth angle. So basically we're just going to simplify it as much as we can, and it's okay to have sine of x and cosine. You're just not allowed to have any other trig, okay, if that makes sense. So okay, so basically, we're going to look at the double angle formulas to rewrite this. So if you look at the double angle formulas for sine, we know that sine of 2x equals 2 sine of x times cosine of x. So we go from double to single, okay? So one of the things you should know is that, again, this angle is quadruple. So I can rewrite 4x, that angle, as 2x plus 2x, okay? All right, so bear with me, and I know you're probably thinking, what is going on here? Okay, so ready? We're actually going to be applying an old property as well, so just kind of bear with me. So we're going to write sine of 2x plus 2x, okay? So now you're wondering, okay, what are we going to do here? So think of this as, well, let me use a different color. Think of this as u and this is v, okay? From one of our properties that we learned in the previous lesson. So now I wrote it in pink, so I'm going to show you. Hopefully you have your index card, okay? So ready? The property that we're going to be using is sine of u plus v. And I'm going to write it on this side, so let me move it forward. Sine of u plus v is sine of u times cosine of v plus, and hopefully I have enough room, cosine of u times sine of v, okay? So we're actually going to be applying quite a few properties, okay? So again, I want to just remind you, I took sine of 4x and I split it as sine of 2x plus 2x. And now this is sine of u plus v, so we're going to be applying this property. We're not going to be applying this property yet, so hold off on this one, okay? Hold off on this one, but this is one that we will be applying. And right now we're just going to be applying this one. So maybe I was premature in telling you this one, but we know we're going to be applying this one because it's a double angle formula, okay? But right now what I'm going to do is not apply that one, so ignore it for now. Just rewrite this in terms of our sum formula, okay? So ready? That'll look like, let me move this up. And I'm going to do it in pink just so we can keep track, okay? So basically that's going to look like this. Sine of 2x times cosine of 2x plus cosine of 2x times sine of 2x. And if you're wondering why is it looking like the same, that's because remember u and v are exactly the same in this case, okay? So, okay, so am I done? No, I just applied the sum formula. So sine of 2x times cosine of 2x plus cosine of 2x times sine of 2x. These are exactly the same, so I can simplify this by saying this. Twice, remember, it's like saying 3 times 4 or 4 times 3. You still get the same answer. So this is twice. So I don't care which one you use. I'm just going to stick to the first one. Sine of 2x times cosine of 2x. Because these are both exactly the same. They just, again, it's like 3 times 4 or 4 times 3. So I could just say twice this, okay? So this was just me using the sum formula that we learned in section 5.4. And now this is me combining like terms. And the reason why I'm keeping this on the outside is because now I'm going to go ahead and apply this property. Okay. So I'm going to apply this property for sine. So ready? So now I'm going to use my green marker. Okay. So sine of 2x is going to be, and this is for this one, 2 sine of x times cosine of x. Okay. I'm still going to keep that 2 on the outside, but leave it there, okay? Now, I just used the double angle formula for this one, but notice we still have a double angle there. So we have to use the double angle formula for cosine. So now if you you recall for cosine, there's actually a couple of double angle formulas. There's 3 as a matter of fact. And if you're wondering which one do you use, technically it doesn't matter because as they all 3 of them have sine and cosine, okay? So I'm actually going to be applying, I think the most simplest one for me is probably the third one. Okay, to be honest, it doesn't really matter, but I'm just going to stick to the third one. Okay, so now let me show you. I'm going to put a double line. Okay, so this one I'm going to rewrite it as 1 minus 2 sine squared of x. Okay, so this is what I have so far. Okay, all right, so awesome. Again, I've just replaced these with the double formula. Okay. Okay, so I'm running over the room. Let me grab my second whiteboard. Okay. And let me move that a little bit. Okay, let me move that up. Okay, so now if you're wondering what do we do, then what you could do is start distributing. Let's distribute the 2 in here. And basically all you're going to end up with is 4 sine of x times cosine of x. I'm still going to keep the parentheses on purpose so you can see something else. And then, so consider this like one term because it's all being multiplied. This is a binomial. So if you're wondering what the next thing we're going to do is we're going to distribute. Okay. So now we should have 4 sine of x times cosine of x because that we multiplied by 1. And now we're going to multiply this by negative 2 sine squared of x. So basically that'll give us negative 8 sine cube of x times cosine of x. And is there anything else I can do? And the answer is no, there's nothing else. We don't have double angles anymore. None of these are double angles. So we got rid of all our double angles. Okay, so we went from 4 angles to now single. See, they're all single. You want to ignore the cube because remember the cube represents the sine, not the angle. Okay, and honestly, there's nothing else you can do, so you're done. As long as you don't have any double angles, you're okay. Okay, so I'm gonna just kind of go over this one more time. So sine of 4x, remember your angle is 4 times. So you can ignore this for now, but I basically separated our angle into 2 double angles. So 2x plus 2x. And so now I use the sum formula that we used in section 5.4. So I rewrote it as sine of 2x plus 2x. In this case, 2x is u and 2x is v. So this was the sum formula for sine. And I just rewrote this. So sine of 2x times cosine of 2x, and then plus cosine of 2x and sine of 2x. Simplified it by combining like terms, and then you just get twice that. And then, of course, we still have double angles here, so I just separate it by using the double angle formula for sine, double angle formula for cosine. And then basically just distribute and simplified it. And there's nothing I could do here, okay? Now, if you're wondering, well, there's a cosine here and a cosine here, you can factor that out. There's a 4 here and 8 here, you can factor out a 4. Don't do that because we just distribute, so why would we go backwards and factor it out? So might as well leave it here, There's just nothing we can do anymore. Factoring it out is not going to do anything. So you don't want to do that. Okay? And that's it. All right, boys and girls, so now you have enough to do example 3, the checkpoint. So work that out and then check your solutions.